All right, so this is number 12 on page 313. And x squared minus 4x plus 13. So f of x equals x squared minus 4x plus 13. Okay, so first thing I want to look at is, can I factor that? And the factors of 13 are only 1 and 13, so it can't be factored. All right, so then we're going to find the zeros, we're going to either do the quadratic formula or complete the square. Which one do you want to do? All right, so if we use the quadratic formula, we've got the opposite of negative 4 over 2 times 1 plus or minus the square root of negative 4 squared minus 4 times 1 times 13 divided by 2 times a, or 2 times 1. So these two negatives here make a positive. So we get 4 over 2 is 2 plus or minus. And under the radical, we have 16 minus, what's 4 times 13? 52. Okay, so 16 minus 52 is negative 36 over 2. So the square root of negative 36 is, okay, so we get 2 plus or minus 6i over 2, which gives me 2 plus or minus 3i. So did you find your mistake? Yep, that'll do it. So then when we write it in factored form, then we get x minus 2. And here's the one thing, okay, that this always happens, right? So when they tell you they want you to write it as factors, then since there's a plus or minus here, okay, I'm always going to have just the opposite sign of this and then one of each of these. So I have x minus 2 plus 3i and x minus 2 minus 3i. So, because remember when you're subtracting, this becomes a negative, and that would be a negative, and that would be a positive. So basically you just end up with the opposite sign of this, and then both the plus or minus there. And that's the end of that one. Anything else from those? Number 8? Okay. All right, so number 8. Ooh, that's loud. I'll take care of that. All right. Okay, so they want us to find the multiplicity here. All right, so we need to find the zeros and then the multiplicity. And remember that multiplicity is just about whatever the degree is of each factor. So each factor has degree 1, so then I just need to know what the zeros are. So we have zeros at negative 1/6, 1/5, and negative 1/4, and those all have multiplicity of 1. Number 8. Okay. All right. Anything else from there? Number 18. Okay, number 18 says x to the 6 minus 64. All right, so, and they want us to write this as a product of factors in the complex number system. So first thing we have to do is factor this. Okay, this is the difference of two squares, right? This is x cubed minus 8 and x cubed plus 8. Well, now then I have the difference of two cubes, x cubed minus 8, and the sum of two cubes, x cubed plus 8. So we can factor both of them. So we have x minus 2 times x squared plus 2x plus 4. And that is what I get when we factor this one. And when we factor this one, we end up with x plus 2 times x squared minus 2x plus 4. So we have zeros at positive 2 and negative 2. And then the other two parts, here and here, you have to use the quadratic formula for. So you should actually have 6 answers. So you get x minus 2, then when you factor x squared plus 2x plus 4, so there's 3. X plus 2, and then x squared minus 2x plus 4. When that's, use the quadratic formula there, you get 2 more. So, yep, you should have 6 answers when you're done. Okay, is that good enough? You want me to do one of them? Right. Anything else? All right. Yeah, let's keep going. All right, so I figured out if I take this video when I'm done with it, I actually have Windows Movie Maker on my computer at home, and I can cut and paste or cut stuff if I really want to. So, but all right, so you had to do 3 through 5 then. So the answer to number 3 is here. So we had, and these were up if you go to that channel on YouTube. Okay, they're there. Your examples are there now, right, Chris? Did you find them?
My internet was like going in and out.
So I actually had this one up on, not this exactly one, but I had one like a problem like this. So you could have looked at it. And anybody actually go there and look at them? Has anybody ever gone there yet and looked at any of the videos? Okay, John has. All right, all right. It's there. I mean, I'm actually expecting that you're going to do that. Because when you come into class, you should at least have, that if you're not sure what to do at first, then go find something that looks like that so you can find it and know how to do it. But all we did here is take the zeros. So let's make it a little bigger. So the thing to remember, so we had a 0 at negative 3. I need a pointer. I'm using a smiley for my pointer. 0 at negative 3. And if we have a 0 at 2 minus I, well, then that means we have a 0 at 2 plus I also, the conjugate. Right? I need something to really point on there. Huh? Yeah, but I mean, so it shows up on the screen. So then when I write them in factored form, then here, we've got x plus 3, then x minus 2 plus I, and x minus 2 minus I. So like I was just telling you guys, that the fact I have 2 plus or minus I for zeros here, that means when I write it in factored form then, that we're going to have the x minus 2 plus I and x minus 2 minus I. So all it is when I write it in factored form is the opposite of the 2, and then both of the plus or minuses. Now when you multiply them then, always multiply the two, any of them that have i's in them, multiply them together first. Because you want to get rid of the i's. And the thing is that when you multiply them, it is the difference of two squares. So that gets rid of all the middle terms, basically. So you notice that when I do the multiplication down here, okay, so I multiply everything by x, multiply x by everything, then negative 2 by everything, and then I by all of them. And so you end up with a negative ix, positive ix, positive 2i, and a negative 2i. So all the things with the i's in them are going to be gone. Okay. And what's I squared? Negative 1. So here we have the opposite of negative 1 is going to give me a positive 1 there. So you'll have x squared minus 4x plus 5. And then we just have to multiply that. So the big thing is that if they give you a conjugate 0, or they give you a complex 0, then you have to find the conjugate of that also. And that's a 0. You can't forget that. All right, number 4. They want us to factor over the set of real numbers. So here's the thing I have to do now. Since they give me a 0 at 2 minus I, that tells me there's also a 0 at 2 plus I. Okay? So what we need to do then is that I need to write them in factored form and multiply. Right? So I get x squared minus 4x plus 5, which this was the same as the problem we just did, wasn't it? Okay? Didn't I have those same zeros? Okay, so if you've noticed that, it would have helped you. And then you have to come over here and do our favorite thing, long division. And if something's a factor, what's the remainder? 0. Okay, so I didn't finish this here because I'm going to end up with 0. All I need to know was that negative 7 times x squared is negative 7x squared. Now the one thing it says here is it says factor over the set of, over the set of real numbers. Okay. So since I'm doing over the set of real numbers, then x squared minus 7 is fine for my other factor then. But in number 5, where they say they want it over the set of real numbers and complex numbers, so if they want it over the complex numbers, then I would have to take this x squared minus 7, and I actually have to, yeah, you have to factor it. Well, when I factor it, I just get square root of 7. So, what's that? Oh, wait a minute, I'm sorry, this is not done. There's one more line here. This is x squared minus 4x plus 5, and then x minus the square root of 7, and x plus the square root of 7. That's the final answer. Because square root of 7 is a real number, right? It's not an integer, but it's a real number. So if it says a factor over the set of real numbers, then it would look like this. If they said factored over the set of complex numbers, then I would have to take this part here and put it down here instead of x squared minus 4x plus 5. And number 5. You want me to do this one completely? All right, so let's go and do that one. Okay, so first thing we want to do this problem then is graph it. So take the function and graph it first of all. So put it in your y equals. Because they don't tell us any zeros, so we need to try and find some. so x to the fourth, 5x cubed, plus 2x squared, plus 22x minus 20. So graph it. Do you find any real zeros? Where at? Negative 2 and 1. Okay. So we can see from our graph here that we have negative 2 and 1. I'll check my table. And there's 1 at 1 and also at negative 2. All right. So we'll start with them. So we have zeros at negative 2 and 1. So what do I need to do now? Yep, we got to do synthetic division then with those two numbers. So I'm going to use 1 first of all. That's an easier number to work with. So 1, negative 5, 2, 22, negative 20. So we bring down our 1. And then just continue through the process with synthetic. Once you get done with you should end up with 0. Better end up with 0. Okay. After you do it with synthetic division with 1, then we're going to do synthetic division with negative 2. And use those same numbers you just got for your answer. And you should end up with 0. So it asks us to factor over the set of real numbers. So if I factor it, second. Factor it with real numbers, then we'll get x minus 1, x plus 2, and x squared minus 6x plus 10. Now, how do I know that that x squared minus 6x plus 10 isn't going to produce real factors? How do I know that they're imaginary right now or complex instead of real? What? That's not why. But nice try. Okay. Well, I could always have radicals, right? Just like we did in this one here, we could have square root of 7 or something like that. But how do I know that this isn't going to produce, oops. How do I know that this is not going to produce real factors? Look at your graph. How many times does that graph cross the x-axis? Twice. If this x squared minus 6x plus 10 was going to produce real factors, how many times would the graph cross the x-axis? 4 times, okay? It would cross it 4 times. So this is the only answer for real factors is here. Now when I want to write it with complex factors, I need to take x squared minus 6x plus 10 and do the quadratic formula or complete the square, whichever one you like. I know you guys prefer quadratic formula, right? All right, so So we'll go ahead and do the quadratic formula. Okay. Square root of negative 4 is 2i, and 2i over 2 is I. Okay, so this would be 3 plus or minus I. So then when I write it as factors, we're going to have x minus 3 plus I and x minus 3 minus I. And that would be for the complex factors. Now, I could have just, when I got to the point where I had this x squared minus 6x plus 10 here, I could have just done the quadratic formula then, and then that would have told me that when I got 3 plus or minus I, the other ones are complex anyway. So I didn't necessarily have to look at my graph, did I? I could have just done the quadratic formula and would have found that those are non-real anyways. So whether they are real or not doesn't matter. Okay. All right, last little bit here. An expression that has even degree of 4 or greater may have only complex roots sometimes. Zeros and factors of such functions and expressions may be difficult to find, and the techniques illustrated in this chapter are of little use sometimes. However, functions of odd degree must have at least one real zero, and the corresponding expression must have at least one real linear factor. So therefore, cubic expression can be approximately factored by estimating one zero, which yields the real linear factor. Using synthetic division, then we'll determine the quadratic factor. And then we can use quadratic formula. Okay, so we looked at a couple things here then. All right, we took our factors that we knew, the zeros that we knew, wrote it in factored form, and then we're able to find the polynomial for it. And then we were able to factor. So, okay. Any questions about that, or are we good? Yes, Chris.
On example 5,
Mhm.
you said we had the graph to find our zeros. Well, on the quiz, it says no calculus.
Oh, man. So what are you going to do then in that case? What would you do?
That's what I'm asking.
I've probably made it easy enough that you're, okay, that you'll be able to do that. So, okay. But what is it? Well, we look at rational zeros then, right? Okay. Remember how to find rational zeros? Okay, because that's a good question. Okay. How do we find rational zeros? Yep, the factors of the constant. Factors of the constant over the factors of the leading coefficient. So in this case, that would be 20 and 1, wouldn't it? Okay, so the only factors the only thing you'd have to check would be 1 through, 1, 2, 4, 5, and 20 if you needed to. Okay, but I'm sure it's going to be something basic where you don't have to. Or maybe I might even give you the graph and say, okay, here's the graph. Find the factors for me. Okay, or write it in factored form. All right, anything else? That's a good question. All right, so let's go ahead and then get in your